All right, we left off looking at what do we do if we need to find a probability and the number that we're interested doesn't fall exactly on a standard deviation. So we're going to use technology to do that. And before we get into the technology, I want to explain a little bit about how these work. And I'm going to define a new term that'll help kind of illustrate that. So this is our cumulative probability distribution. And so what it does is it adds up all the probabilities starting here at 0, and it'll add them all up until it gets to whatever number it is that you're interested in. So what that means is if you put 1.48 into any of these probability calculators, it's always going to give you the probability below that number. So if you needed the probability that was greater than 1.48, you're going to have to adjust that. And I'm going to show you how you can do that with the app that we're going to use in this class. So to fill in this blank, we're looking for a value of x in a distribution. This is the proportion of observations that are less than or equal to x. So it's always going to give you this left side here. All right, so the app we're going to use is the Rossman Chance Normal Probability Calculator. And the address is here, but there are links to it on Canvas. So if you're on that Chapter 3 page or you're on the Unit 4 announcement, you should be able to find that link there. So let me show you how this is going to work. So the first thing you do when this loads is you're going to put in your mean and standard deviation. You're going to ignore this one here, so just don't even worry about that. So your first thing is put your mean and standard deviation in, and then you're going to choose scale to fit. And so what that does is it redraws this for the numbers that you put in. And so here it put in that mean of 20, and our standard deviation here was 2. So it counted up by 2s and counted down by 2. So this is the same sort of thing that we were doing by hand with the empirical rule, but this app will do it all for you. So your third step is you're going to click this checkbox here. So normally that's unchecked. You're going to click that, and then you can put the number that you're interested in this box that says X. Okay, you can ignore this middle box for a little while, the Z. And so the probability here is going to be this number here. So you'll notice that they give these probabilities in decimals, and that's totally, if it says, no matter what it says, if it says percentage, proportion, probability, if you write this number as is, that's totally fine. You don't have to convert these to percentages or anything like that. Regardless of what the question asks, I will happily take it as long as you have one of the versions of it that is correct. Okay, so we can put the 18 in, it'll give us the probability, and then you'll notice this inequality sign here. We can actually click this guy, and that will change whether it's the below or above. All right, so before we go to the app, I want to look at this problem down here and kind of color the picture in so we can understand what's going on. So we're going to work with that commute time problem that we looked at earlier that was normally distributed with a mean of 20 and a standard deviation of 2. And so this one says, estimate the percentage of time it will take more than 21 minutes. So 21 is right here, so it does fall between the mean and the first standard deviation, so we can't really estimate that with the empirical rule. But we can look at this and we can kind of eyeball it. So we know it's definitely got to be less than 50%, but it's got to be more than 16% as well, because this would be the markup for 16. So somewhere between 16 and 50. So we'll go put that into the calculator in a minute. And then this one here says, estimate the percentage of time it will take between 15 and 20 minutes to arrive to school. So here's 20, 18, 16, 14. So 15 sits right in here. So we're looking at this piece right here. So again, we also know this one is less than 50, but probably a different number than this one, but I guess we'll find out. Okay, so now this one, you actually have two numbers here, right? So when that happens, you're going to click this other box on this app, and then it'll allow you to put two numbers in, and this thing here will pop up, and it'll give you the probability either between, which is this shaded part here, or the probability outside, so those where those two tails are. All right, so I'm going to pause the video for a second, and I'll rejoin you on this app. So if you want to go ahead and load that up. All right, so here is the Rossman Chance Normal Probability Calculator. and it always defaults to a mean of 0 and a standard deviation of 1. So that's known as the standard normal distribution, and we'll talk about that more in another video. But the commute time video, problem, sorry, has a mean of 20 and a standard deviation of 2. So I'll put both those numbers in and I'll click scale to fit. So now you notice it drew this out and it put the 20, 22, 24, and so on. And then my next step here is I'm going to click this checkbox, and then I want to estimate the percentage of time it will take more than 21 minutes. So I'm going to put a 21 in here and I'll push enter. And what's nice about this is it draws the line where the 21 is, and then it shades the side, that blue or that darker side on the left. It shades that so you can see that that's the probability number that it's giving you. So in this case, we know that we want to find the probability that it takes more than 21 minutes. So we're interested in this side over here. So I certainly could take this and subtract it from 1, but this app is really cool because I can click this inequality sign and it should flip over here. Oops. There we go. So it flipped over, and so now it's giving me the probability that it's greater than 21, which is 0.3085. So that would be 30.85%, and you can write it either way. I'm totally fine with either. And then the next one said, estimate the percentage of time it will take between 15 and 20 minutes. So we have two numbers here. So I do need to click both of these check boxes down here, and I'll put a 15 in the first box. And so put the line there, and then I'm going to put a 20 in the next box. So there's the line for the 20. And so the probability between is this part that's shaded, and then the probability outside is this part on the right and the left added together. So we want the probability that it's between 15 and 20, which is this part here. And so that probability is going to be 0.4938, or about 49%. All right, and then the last question for this one. So there's kind of three different versions of asking the same question, and they are as follows. Below what time would the lower 10% of arrival times be? What is the cutoff value for the lowest 10% of arrival times? Or what is the time for the fastest 10% of arrival times? So sometimes you have to kind of think about these in terms of the actual practicality of the situation. So when we're looking at these lowest ones, this is actually related to the fastest times. So I'm interested in this 10% that is somewhere here around 12, 14, 16 is kind of what I want. So we talked about changing the x. What I'm going to do now is I'm actually going to change this probability instead. So I'm going to put 0.10 in there, and I'll push enter. Okay, so you notice that it moved over to the right-hand side. So it did give me 10%, but not on the side I want. So I'm going to flip it back over. So I'll push this inequality sign, and I'll change it back to 10%, so 0.10. And that's where I'm expecting that line to be, because I expect 10% to be this lower 10% to be on the left side. And so when it asks for the cutoff value, it's asking for x. So far we've learned if I give you x, you give me the probability. And now you can put the probability in and get x back out. So we get 17.437 for x there. So 10% of the time you're going to arrive to school, or your commute time is going to be 17.4 minutes or less.